Now we're going to move on to our OSPF lab. As I depicted in the diagram on the board, I'm going to create area 0 between router 1, router 2, router 3, and router 4. I'm going to create area 51 behind router 2 over here, and I'm going to create area 1 behind router 1 over here. So let's go into router 1. I'm going to begin this time on router 1. And I'm going to enable the OSPF process on the router by saying router OSPF and hit enter. And now again, it is telling me that this is an incomplete command. So I pull up the command again and execute the help feature by saying question mark. And now it is asking me for a process ID, which can range between 1 and 65535. Now, with EIGRP, the number it was asking me was the autonomous system ID. The autonomous system ID is globally significant, which means every router in your network needs the same number. So we picked 100 for EIGRP. The process ID, however, is locally significant. So every router in our network may run a different process ID, and those routers will talk to each other. However, that is bad practice. So we are going to stay consistent and pick 100 again. Our prompt changes to the router prompt. And now we are ready to do our network statements, just like we have been doing for RIP and EIGRP. So I'm going to say network 150.101.45.0. Next, it is asking me for a wildcard mask or a wildcard bits. This works the same as it did in EIGRP. So once again, our mask on the 150 network is 255, 255, 255, 248. If we subtract that from 255, 255, 255, 255, we get 0.0.0.7. Next, if I execute the help feature, it is asking me for the area ID. Remember, between router 1, 2, 3, and 4, which is network 150, I'm going to create area 0. So I simply say area 0. Next, I'm going to go ahead and take care of the other side, where I'm going to have area 1. So I did a network statement for this side on router 1 where area 0 exists. I'm going to go ahead and do a network statement for this end, the link between router 1 and router 201, which is going to be area 1. So let's go to router 1 again and say network 200.200.200.0. And my wildcard is going to be 0.0.0.3. Since my mask is 255, 255, 255.252. And this is going to be area 1. Now let's execute a show command and see what OSPF has done so far. We do the command do show IP OSPF and hit enter, and you see that OSPF went ahead and picked a router ID for itself, and the router ID was picked as the 200.200.200.1 address. Now, if I look at router 1's show IP interface brief, do show IP interface brief, I will see that on fast Ethernet 00, I had the address 150.101.45.1 command, or 150.101.45.1 IP, and on serial 000, I had the 200.200.200.1 IP. Since I did not execute the router ID command and manually pick a router ID, and since nor did I have loopback interfaces in place over here, as you see, there are no loopback interfaces on router 1, the router went ahead and picked the highest physical IP. So the highest IP configured on a physical interface, which happened to be 200.200.200.1. Now, what if I want my router ID to be tied into a loopback address, which is good practice because loopback interfaces don't fail unless the whole router fails. I don't want at some point serial 000 to fail and then end up taking down my whole OSPF. So I'm going to go ahead and create a loopback address on router 1. I'm going to say int loopback 0. That brought up my loopback interface, and I'm simply going to give it an IP address of 1.1.1.1 with a mask of 255.255.255.255. For loopback interfaces, this mask or mask of /32 is allowed. Now, did the router change over? Do show IP OSPF process. Do show IP OSPF. Did the router change its router ID to the loopback address? No, it did not. I actually have to clear the OSPF process, bring it down, and then when it goes back up again, it hopefully will pick the 1.1.1.1 address. So do clear IP OSPF process, and I say yes. That takes down my process and brings it back up again. And now if I look at the do show IP OSPF command, my router ID has been picked as 1.1.1.1 because the router prefers the highest configured loopback address as its router ID over a physical interface address. However, it is good practice to hard code this address with the router ID command anyways. So I go back into my routing process, router OSPF 100, and I say router-ID or router-ID 1.1.1.1 and hit enter. It's asking me to clear the process again because it thinks that I entered in a new router ID, so I'll go ahead and comply with it. The reason you want to hard code your router ID is because let's say I have picked 1.1.1.1 as my router ID. And then at a later date, I create another loopback address that has the address 200.1.1.1. And then at another later date, the router reboots because there was a power outage. When it comes back, it will come back with the router ID of 200.1.1.1, not 1.1.1.1, because it will automatically pick the highest loopback IP address. But if I want to keep it at 1.1.1.1, I should hard code it. Now, just a little side tidbit that I want to show you. What if I pull out this router and I go into it? And remember, this is a brand new router I pulled out. Let it boot up. And I try to start the OSPF process on it. Remember, this is a brand new router. So if I do the show IP interface brief command, there are no IP addresses assigned on it. If I try to start OSPF, router OSPF 100, it says OSPF process 100 cannot start. There must be at least one up IP interface. So on a router without any IPs, OSPF will refuse to start. Why? Because the first thing OSPF will do is go looking for a router ID. And since it can't find itself a name, it won't begin. It won't start the process. Let's get rid of this router. Okay. We're done with router 1 at this point. I'm going to go ahead and do router 2. So before I even begin the OSPF process on router 2, I'm going to go ahead and create a loopback, interface loopback 0, IP address 2.2.2.2, 255.255.255.255. Then I'm going to begin my OSPF process, router OSPF 100, and do my network statement for the 150 network, network 150, 101, 45. Now this time I'm not going to pick the network address. I'm going to pick the IP address on router 2's F00 interface. As you remember, or should remember from EIGRP, when you don't pick the network address in your network statement, instead you pick the IP address, you use the all zeros wildcard. And this goes into area 0, and then network 10.10.10.254, which is the F0/1.10 interface address. And with the all zeros wildcard, this I said I'm going to put in area 51 because I think it's funny. Then network 20.20.20.254, a wildcard of 0.0.0.0, and area 51 again. Let's look at our OSPF, do show IP OSPF, and you see that my router ID was automatically picked as 2.2.2.2. I am, however, going to go ahead and hard code that anyways because that is best practice. And again, it asks me to clear the process. Do clear IP OSPF process. I will save my work and move on to router 3. Quickly get router 3 done. Create a loopback address on router 3. So int loopback 0 IP address 3.3.3.3 255.255.255.255. Start the OSPF process. Give hard code my router ID as 3.3.3.3. Then say network 150.101.45.3 and follow it up with all zeros. Since this is the IP address, not the network address, area 0. Save my work. Go to router 4 and do the same. Interface loopback 0. IP address 4.4.4.4 255.255.255.255, and then start my OSPF process and do my one network statement 150.101.45.0. This time I am picking the network address, not the interface address on F00, which should be 150.101.45.4. I'm not using that. Instead, I'm choosing or opting to choose the network address. Hence, my wildcard is going to be 0.0.0.7. Once again, I simply subtracted my subnet mask, which was 255.255.255.248 from all 255s, or from all 255.255.255.255, and I get a 0.0.0.7 wildcard and area 0. Let's go ahead and finish up router 201, and then we will look at our work. So, interface loopback 0, IP address 201.201.201.201, 255.255.255.255. I simply matched the IP addresses for the loopback 0 interfaces on each router to the router number. So 1 was 1111, 2 was 2222, 3 was 3333, and so on and so forth. Now I'm going to start my OSPF routing process and execute my one network statement, which is network 200.200.200.0. The mask on this point-to-point link is 255.255.255.252. Subtract that from all 255s and you get 0.0.0.3. And this is going to be area 1. Save my work. And let's go check our stuff from router 1. So I log into router 1. And execute the command show IP OSPF neighbor. So we are on router 1 checking our show IP OSPF neighbor command. And router 2222, which is router ID 2222, which is router 2, shows a priority of 1, and it also shows that I am fully adjacent with router 2, and router 2 is the DR. Router 3, I am also fully adjacent with. However, router 3 is a DR other, which means it's not a designated router or a backup designated router. Same with router 4. So where did my backup designated router go? Let's look at the topology from router 4, or look at the neighbors from router 4. So if I execute the show IP OSPF neighbor command from router 4, I find out that router 1, where I was sitting originally, is the BDR, or the backup designated router. So in this topology, I do not want a backup designated router. Usually, best practice is that you do not let OSPF elect a backup designated router. You do not want, once the DR goes down, or if the DR goes down, you want to be informed of it. You don't want a backup designated router all of a sudden picking up the role of a designated router, because the designated router for area 0 will be passing a lot of traffic. So you would have spent a lot of money on that router. If that router goes down, you want to know about it. You don't want OSPF to automatically elect someone else as the DR and then end up crashing that router because it cannot handle the load. So I want router 1 to be my designated router and all other routers to be DR other routers. I do not want a BDR in my topology, or a backup designated router in my topology. Now, I could go increase router 1's router priority to something higher than 1. As you see, everybody's default priority is 1 on area 0. Or the best practice is that I go and change router 2, 3, and 4's OSPF priority to 0 to exclude them completely from the backup designated router and designated router election. So I go to router 2 and I go into interface fast Ethernet 0/0, and I change the router priority with the command IP OSPF priority 0. Then I clear the process for OSPF. So I take OSPF down, and when it comes back up, it'll come back up with a priority of 0. And you see all my neighbors were reset. Now I go to router 4 and do the same. I go into interface fast Ethernet 0/0 and say IP OSPF priority, if I can type, OSPF priority 0, and do a clear IP OSPF process to reset the process so it comes back with a priority of 0. Do the same on 3. Interface fast Ethernet 0/0, IP OSPF priority 0, do clear IP OSPF process. And now let's go check on router 1. But before checking on router 1, I also have to clear the process here to make sure that it becomes the designated router. Now, by default, router 1's priority was 1. Everybody else's priority is set to 0, which means they can't even participate in the designated router and backup designated router election. So router 1 should have become the DR. Let's find out. Show IP OSPF neighbors. And sure enough, I see that router 2 is the DR other, router 4 is DR other, and router 3 is a DR other also, which means I should be the DR. We will go check that in a minute, and you see that router 2, router 3 router 4 and router 3's priority has been set to 0. Now, all of these three routers are fully adjacent with me, which means they have exchanged their full database or link state database with me. How about with each other? Well, let's find out. Let's go to router 4 and execute the show IP OSPF neighbor command. You see that router 4 is only fully adjacent or has exchanged its full database only with the DR. With router 2 and router 3, it is only in the two-way state, in the neighbor change machine. Or in the neighbor state change machine. They are in the two-way state, which means router 3 has seen its own router ID in hello sent from router 2. As I iterated before, you only become fully adjacent with the DR and the backup DR. Since there is no backup DR, you only become fully adjacent with the designated router. Now, let's go check our routing table on router 201. So the routing table on router 201, show IP route OSPF. I hit enter. I see network 10, network 20, and network 150 is available to me through OSPF. This O all the way on the left-hand side designates that this is an OSPF route. Then this IA that you see means that this is an inter, I standing for inter, A standing for area. All these routes are inter-area routes. So, if I look at my topology, of course, on router 201, I'm sitting in area 1. These routes are coming from area 0 and area 51. So, hence, they are inter-area routes. Then, in brackets, you see the 110. As always, this first number is the administrative distance. So, this first number is the administrative distance for OSPF, which is 110. The 66 here is your OSPF metric. Now, OSPF uses something called cost as its metric. So OSPF uses cost as its metric. And cost is defined as 10 to the power 8 divided by bandwidth. It's that simple. 10 to the power 8 divided by bandwidth. So for a 100 megabyte link or 100 megabit link, 100 megabits is 100,000 kilobits, and then you add another 3 for bits. So you have a 1 with 1, 2, 3, 4, 5, 6, 7, 8 zeros. If you divide that by 10 to the power 8, which is a 1 with 8 zeros, you end up getting a 1. So the cost of a 100 megabit per second link or 1,000 kilobit per second link is 1. If we look at our show IP OSPF interface, serial 010, which is the interface running OSPF, you see that my cost on a 128K link is 64. Let me go check the cost on router 1's F00, and you will see that it says 1. Show IP OSPF interface fast Ethernet 0/0. So over here, the cost says 1. So for a 100 megabit per second link, the cost is 1. The priority for this interface is 1, and we know that is the default priority. It also shows that my hello timer is 10 seconds. My dead interval is 40 seconds. So the dead interval is usually set by default to 4 times the hello timer. Now, going back to router 1, I also want to point out, if I say show IP OSPF neighbors, on the link with router 201, you see it simply says priority 0 by default, and it says full/hyphen. Over point-to-point links, there is no designated router or backup designated router election. Doesn't make sense. There are only 2 routers. There's only going to be one adjacency between them. So it doesn't make sense to elect designated routers or backup designated routers. So from the point of view of router 201 also, you will see that there is no DR or BDR. Show IP OSPF neighbor. So router 201 is neighbors with router 1. The priority is set to 0. And there is no DR or BDR. I am fully adjacent with router 1. Lastly, 2 more things. Let's look at our debug IP packet. And you see that hellos are being sent to the address 224.0.0.5. Now what happens if I turn off debugging and then I debug IP OSPF events and clear this process, clear the OSPF process. So clear IP OSPF. Did I not turn off debugging? U space all. Okay, now I turn off debugging for debug IP OSPF events, and then the events, I'm going to see the hellos, of course. Clear IP OSPF process, and I say yes. Now, those neighbor states that you saw that I discussed earlier, you can catch some of them here. I was able to catch a few of them, so I cleared the process. As you see, I cleared the process, and then you see two-way communication, and then you see xstart and database description packets being exchanged. Then you see xstart, then you see exchange, and at some point it should say full. So you have elected the DR and BDR, and you're still in xstart. Well, we didn't get to see the full state, but at least we got to see some of the state changes. Oh, here we go, full. So when you are fully synchronized your database with router 3, with router ID 3.3.3.3, it went to full, or from loading to full. So we even got to see the loading state. The next command we're going to look at is the show IP OSPF database command. And you see that this is your link state database for area 0. Over here, the link state database for area 1 starts. So let's look at the link state database for area 0. This first stanza is your router LSAs or your type 1 LSAs. This second stanza is your network LSAs or type 2 LSAs. And this third stanza is your type 3 LSAs or summary LSAs. Okay? For the type 1 LSAs, you see each router is, the advertising router is each router produces one type 1 LSA. Okay? And the link it's advertising is the 200 link, and well, the link it's advertising is represented in the router's router ID. Then you have the network link states, which is your type 2 LSAs, and the advertising router is the DR of that network, which is router 1. Then you also see that the two ABRs, which is router 1 and router 2, this 200, 200, 201 is router 1, and router 2 are producing your summary LSAs because they are the ABRs and they're injecting networks from one area into another area. We do not see a type 4 or a type 5 LSA in our database because we do not have external routes. That is not part of CCNA. The last thing I'm going to do with OSPF is to show you how OSPF authentication works. So we're going to authenticate area 0. So I go into router 1 and I go into the OSPF process by saying router OSPF 100, and then I say area 1 authentication. Then I go to the interface facing router 201, so interface serial 000. Because area 1 exists between router 1 and router 201, I go into this interface and I say IP OSPF. Now, I can either do simple text authentication, clear text authentication, or I could do message digest authentication, which is a lot more secure. Clear text authentication will send my password across the link in clear text. Message digest will encrypt my password before sending it over. Or actually, the actual password is never sent, only a hash of the password is sent. You see that as soon as I turned on authentication and the dead timer expired on the other side, or on my side, the dead timer for router 201 was brought down. So the neighbor is down. Because now I locally on router 1, I have authentication, but no authentication configured on the other side. So on this end, I'm going to say IP OSPF message digest key, and I'm going to pick a number for the key, key 1, MD5, the word MD5, and then a password. I'm going to simply pick it to be Cisco. I'm going to save my work and go do the same for router 201. I'm going to go into the routing process and say area 1 authentication message digest. I did do that on router 1 now, didn't I? Let me just make sure. Let me check my show run. Actually, I did not do that on router 1. Let me go ahead and change that. I did not say message digest on router 1. I just said area 1 authentication, which is clear text authentication, which I don't want. So no area 1 authentication to take it away. Then area 1 authentication message digest. Save my work. Go back to router 201. And I already have area 1 authentication message digest on this end. Now I just have to enable the authentication on my interface. So interface serial 0/1/0, the interface facing router 1. And then I say IP OSPF message digest key 1. This key has to match on both sides. MD5 and the password has to match on both sides. And pretty soon I should see, if I debug my IP OSPF events, and my adjacency came up. Show IP OSPF process, show IP OSPF neighbor, and router 1 is up, and router 1 and 2 are authenticating each other so that nobody else can unplug that device and plug in their own device and then get all your data. If I say debug IP OSPF events, See, now you're sending authentication information because now the debug command shows that you're sending the youngest key, which is Cisco. Turn off my debugging, and this concludes OSPF.